Okay, so welcome everyone. I'm Jan Oliver Ringert and I'm the convener of Generative Development, the module. And this short presentation will tell you what Generative Development is and why you should be studying it. So Generative Development is the automatic manufacturing of software systems from elementary reusable systems, models and specifications. So basically the important emphasis here is on automatic manufacturing. So we're trying to create software not by writing everything manually in code, but by generating parts of it automatically, and that's the generative part of the generative development. So we're trying to develop software in a more efficient way that can cope with the complexity of today's systems. The introduction, this module is structured as follows here. We started with an introduction, that's the first week. Give an overview and the main concepts of generative development. Then we go into modeling languages. This will be something like 4 weeks in total, where we will look at the unified modeling language. This is something, a standard created by an international group of companies. It's an open standard. Many companies can join, many companies did join. And this is basically for large companies that have an interest in standardizing the way that software is modeled. They are participating here. So there's a list somewhere on the web. It's a huge list. Almost every big player is in there. Then we will look at some of the languages in UML, and this is not only beneficial for generative development, but also for any other kind of software development job where you will maybe talk to clients and develop software models for the requirements or for the system to communicate with others. Some requirements document, they will include software models from the UML. For your final project, you are very likely to create some UML diagrams to illustrate the design of your project. So yeah, this part is beneficial no matter what. Yeah, and then we will look at consistency. So in consistency, what we're looking at is that the models are somehow well formed so that we can read them with the machine and interpret them without any contradictions. So we will look at some examples of the modeling languages that we have learned so far, and what are examples of these contradictions and how can we check them, things like that. And then we will look at code generation. So how can we, from these models, automatically generate code for our implementation of the software system that we are modeling. We will look at two main examples, class diagrams and state machines, because they are the most popular. And then finally, we'll look at reactive systems. So reactive systems, they are in an ongoing interaction with their environment. They read sensors, they produce outputs. So that's a bit different from a normal algorithm that not just gets one input and produces one output, but here it's a bit more complex over time. So for example, traffic controls, they are interactive, they are reactive systems. A robot, a car, all the software in there is reactive, so it takes inputs, it creates outputs, and does so over a longer period of time. And we will look at how we can automatically synthesize implementations for this based on specifications of the system, where we just say what we want the system to do, but we don't tell it how to do it, and then it automatically finds out how this can be done and creates an implementation, if that's possible. Then finally, we will look at software product lines. So software product lines are a technique that allows companies that have many similar products to maintain all the variants in a more efficient way, not just clone and own, where you copy a piece of software and then just say, well, that's the new product. Then if you have some errors in one of the earlier products, you just copied that and there's no way you can fix all of them. So software product lines are a way to alleviate these challenges, and there are many examples of companies using this approach. I have a student right now who is analyzing how this is done in JetBrains that do many IDEs for software development, so you might have heard of that. And we will also have an international conference in Leicester that is organized in our school. This will be this year probably held virtually, but this will be the Software Product Line Engineering Conference. So this is also some important stuff for generative development, because we have high-level descriptions and we can generate the variants. Now, the way this will be taught, we will have 2 hours of lectures every week, and Then we will have 1 hour of tutorial where we usually do some practical things. So we look at some example problems and we will try to formalize them in the modeling languages that we have learned, or we will look at some of the concepts and try to apply them in the modeling in the formalisms that we have learned. So for example, for the software product lines, we will design some software product lines and then analyze some properties of them. And then in addition, we will have computer labs. So the computer labs will be mainly you on your computer being supported by teaching assistants and myself as one of the teaching assistants, and we will try to solve some examples. So in the first part of the module, we will look at software modeling and code generation. And then in the second part, we will look at this automated synthesis part in the computer labs. And there'll be some worksheets that you can solve, and then I'll release some solutions later on with videos, how I solve the worksheets. And in the meantime, you can get help in the forum or by asking a TA, and then the TA will call you. You can do screen sharing, things like that, so we can assist you there. The assessment of this module will be coursework only, so there's no exam, but we have a class test. So we'll start with a homework. The homework will be due sometime after the first half of the module, and we will assess mainly the first introduction, modeling languages, and code generation. This will be done in the homework, so the homework will be very similar to the first part of the computer labs, but of course a bit more kind of your own thing. And this will be some programming, some modeling. You will have to write code that integrates the generated code, things like that. And then we will have the class test. Will basically cover all the parts of the module. And the class test will be on Blackboard. It will be different kind of questions. So the most prominent example of questions will be the multiple answer questions, where you have multiple answers about some topic and you have to select which ones are correct. Then we might have matching questions where you have to match maybe some definitions and some concepts. Yes, and then some other examples would be fill in the gap questions, where you have a sentence and there is some words are missing and you have to fill in the correct words. And some other examples I think would be where you have to calculate the numbers. So for the software product lines, you might get the description of a software product line and you have to calculate how many products there are. But this is stuff that we will practice in the tutorials, and then in the class test, we'll just cover basically some part of the theory and practice that we have done throughout the whole module. Finally, the last part, I want to share some student success stories with you. So the first one is we had some students participating in an international competition in Germany. It was hosted by Audi, and it was about programming these small-scale self-driving cars. And basically the part that really worked best was the generated code, where one of the students created software models and then generated the code. We had some other trouble with the handwritten code, and also Audi itself and many other car manufacturers as well, they use a model-based approach. So we had to integrate our code into their modeling approach. So this generative idea, this is basically all over in these large car manufacturers and automotive companies. They use it a lot. And then another project, this project won a prize in the department for the best distance learning software development MSc project. And what this student did is wrote a code generator for ASP.NET from UML diagrams. So this is basically taking the concepts that we had in this module, putting it in the final project, and then the student won the prize for the best final project. And then another student basically had even more success on an international scale. So this student received the Best Paper Award at an international conference where we published results of the final project of this student. So maybe next year you will be on this slide.